Hello guys, welcome back to the next video in our Roblox scripting tutorial series. In today's video, we have methods of finding children and ancestral parents within models. So as always, let's go to server script service and let's add a script. Rename it. I'm gonna call this FindFirstChild, something like that. And there we go. And before we actually go do anything in the script, I want to show you guys exactly what I'm talking about. So we look in our workspace, and we're looking at all of these children in the drop down of the workspace. All of these instances inside of workspace are classified as children. So if we look at event part or my part that we made in the last video, we can search up in the properties, parents, and a part of this data property, there's parent, and it's telling us our parent is the workspace. So if our parent is the workspace, then a child of the workspace is this part. And likewise with my part right here, if you look right here, the parent is, goddamn, can I fucking go? Thank you. The parent is the workspace, which means that a child of the workspace is this part. Because obviously, if this person is your parent, then you are their child, you know? And the same goes for every single thing here. Not this terrain, I think. Yeah, not terrain. This is a whole different thing. This isn't really like an instance. It's something. Terrain is something with Roblox. That is a whole different video. I barely even know how to use it myself, honestly. And this is the parent and all of these, but you get the idea. Everything inside of this drop down will be either a child, or if it's not inside of it, it is a part of it has the drop down for it. It is a parent of these. And if I add in, let's say I add in something into it, a texture. The parent of this texture is a part, or is the event part. And then the parent of the, so like the hierarchy is this. It goes the part, then the child, and then whatever's inside of the child. So then I can add more stuff. And now the parent of this surface appearance is the texture. The parent of the texture is the event part, and the parent of the event part is the workspace. And you kind of get an idea of how the hierarchy works here. The child of the texture is surface, or the child of workspace is event part, then the child of it is the texture, and then technically this is the grandchild of this part right here. And that's how Roblox uses, or really a lot of actual game engines use this hierarchy of children and parents, which is why in this video we're going to go over FindFirstChild, WaitForChild, and FindFirstAncestor, all these methods of finding children and parents. But you get the idea. We have a part, then we have a child in the part, and then we have a grandchild of the original part, which is going to be a child of the part, which was a child of the part. It's a mouthful, but you get it. This is your grandpa, this is your dad, this is you, and then inside of here, this is your kids, and then this is your grandkid right here, and it's a whole hierarchy. You understand how these work? And it's a whole thing. But for the most part, all of these services, all of these have in the drop downs have parents or have children, and they have parents. And, you know, if we store something inside, then that's a child, and whoever holds it is the parent, which is the pretty basic explanation and rundown of FindFirstChild, WaitForChild, and FindFirstAncestor. Now let's go over some of the methods for FindFirstChild, WaitForChild, and FindFirstAncestor. So let's make a reference to our part. Let's do my part, this one right here. So let's say local my part is equal to workspace. And notice how we usually say workspace dot my part. And the whole point of these methods that Roblox gives to us, these functions, is to replace the dot. We're not going to be using dot for these. We're just simply going to be using find first wait or wait for or whatever. So let's actually do FindFirstChild first. So we can say workspace find first child, and you have all of these drop downs, and there's so much of these that you can just look at them really and read what they do. And after knowing what FindFirstChild and WaitForChild and what these do, you'll have a pretty good idea of what all of these do as well. But these are all just methods that Roblox gives us to help us in our game. So then we say FindFirstChild, and then what it takes in is quotation marks, and then whatever you're looking for. So a string, and then there you go. It fills in automatically if it is there. So boom, my part is my part. It's referenced right. And this is the same really as saying my part is equal to workspace.myPart. These two will return the same thing. The only difference is FindFirstChild will return nil if it doesn't find my part, which in turn won't halt your script. The reason why we use FindFirstChild really is just because if I say like dot my part and my part doesn't exist, well then the rest of the script I'll just get an error and won't run. But FindFirstChild will return it would actually return something back to me if it's either gonna return the part or nil. And if there isn't a part, it'll return nothing, and the script will keep continuing. If there is a part, then it will return our part, and the script will keep running as usual. Now there is a second argument in here, which is the recursive argument. You don't really use this a lot. It's literally just whether or not the search should be conducted recursively. So it's gonna keep looking for the part. You're not really gonna use this. This is a true or false. If you want to use it, you can go ahead. And then we have, oh yeah, one thing to know about FindFirstChild and why we should use it rather than saying like dot my part. The only difference really is, let's say we have like workspace.myPart, right? The only big difference between these two is FindFirstChild is 20% slower according to Roblox. Now the number could be different, but it is definitely slower than just saying this, referencing it with this. Because you have to remember, this is the reference operator right here. We use this dot to reference what we want to reference, and we're using a method right here. We're actually using a whole ass function and we're calling a whole ass function a method to actually find the my part. While using the reference operator, this dot right here, we simply are just saying, hey, here's my part. It's in the workspace. We're saying this is in the workspace. Now, if you are for certain like that my part is in the workspace, then you could use dot my part if you want it to be faster so it doesn't halt your script. But FindFirstChild is the safe method, and I'm probably going to be using it a lot throughout this whole series, using FindFirstChild and WaitForChild and whatnot. I will say though, if you do like use FindFirstChild, you should be prepared to like use a lot of if statements with it as well. So like you'll say like if my part, because something's actually being returned to us, and you don't want to just use my part without actually checking if it actually was found. So that's just something to keep in mind. Also, not to mention with FindFirstChild, I low-key forgot what I was going to say. How did I just do that? Okay, whatever. We'll go on to WaitForChild. I'll remember at the end of the video. Okay. Oh, yeah, I remember. See, the thing is with FindFirstChild and saying, like, dot my part, is that you can use these, like, before something is inside of the game. And that's why we use, like, the recursive. Because, like, we can use this true, and we can say recursive, and this will keep actually looking for this part. I'm pretty sure. Don't quote me on that. I think actually what this does is it looks throughout the children of the part and keeps trying to find like this part with the same name. I'm pretty sure actually. But you probably won't use this a lot. So you can mess around with it if you want, but you don't have to. And yeah, that's really FindFirstChild. Let's do FindFirstChild. Let's write a little note here. Let's say FindFirstChild finds the first, or let's say not instead of find, it returns the first instance with the given name or nil. That's really what it does. It's going to return the first instance with the given name, so this part, or nil if it doesn't find it, and it won't halt your script. Now WaitForChild is way better, and you're going to love WaitForChild because WaitForChild, everyone loves it. So yeah, returns the child of the instance with the given name. If the child does not exist, it will yield the current thread until it does. So you can imagine what that does. If my part does not exist, then the whole script will wait until my part exists. And in the second argument, we can actually define how long we want to wait. Now, if we don't define how long we want to wait, it's going to wait forever. And yeah, this is a great reference to my part. Usually at the top of your script, you would use WaitForChild for like most of your variables. The reason why is because at the bottom of your scripts, like if all of these, let's say we have, let's just do this. Let's copy and paste. At the end of your script, if all of these like were loaded right and were found with WaitForChild, then down here, if I make new variables, I don't have to like say WaitForChild. I can just like call the new part, for example, because if all of these were available, then who's to say this one isn't either? And we don't have to waste time waiting or finding children. We know, hey, this child exists because all of these ones exist as well. It just really, WaitForChild is really good because you're just waiting for the game to load really most of the time. Because sometimes the game, like depending on how fast your computer is, or just how big the server is, or how big your studio project is, WaitForChild is nice because you're gonna actually have to wait for everything to load in before calling them, which is really good for like slower or like larger games. And let's actually get rid of all of these. But I will show you guys, here's another example here. So let's get rid of let's add in, no, we can actually say this. We can say part my, something like part. You can write in something random. This is not in the workspace. This is not a child in the workspace. So what happens when we actually try to run this? So I'm just going to give it a second. And we're going to see not an error in the output, but a warning right here. Infinite yield possible on a workspace WaitForChild, my part. So instead of giving us an error, it's telling us, hey, we can't find this part. And the script is not looking for it anymore. So then here's another practical example. We could say local number is equal to 5. And then we can print out number. And do you think this number is going to print out or even be made? If the script is being halted and we can't really go down here at all because we're still looking for this part, then do you think these numbers are going to be made? No. The script is still up here tripping about with this part. It's like, I can't find this shit. Don't go down here. Don't go down here. I can't find this. Hold on. Let's wait. So infinite or WaitForChild is really good for just holding the script up until something is basically made. You're basically telling the script, hey, don't run until we find this. And look at that. Number was never printed out. The script is not going down here. Now, let's say if we tried to WaitForChild, but for just a couple seconds. Then after 3 seconds of not finding the child, then we'll just skip this whole line and it'll go down. Print number. There you go. Number was found. It looked for 3 seconds. Couldn't find it. That's it. My part isn't declarized. Sorry. We got no part. And that's a really good use case of my part. And then now we have FindFirstAncestor as well. Now, before we actually move on, let's write a little note. WaitForChild returns or waits for an instance before returning it. If not, then infinite yields will be on the script. The script will be yield forever. Now, before we actually move on, I want to show you guys something cool. We can say local my part is equal to workspace WaitForChild part my, something like that. And then in a different script, let's actually make an instance of this part. So let's say local part is equal to instance.new. And then we can say part. And then now we can say part.name is equal to part my. And then let's make this, let's do this. Let's wait 2 seconds before actually making this part. And then I'm gonna say if my part then prints found my part. And now, even though it doesn't exist, we're making a new part from a different script. Infinite yield possible. Oh, the script is taking too long. Oh shit. Okay, maybe we should wait a little bit, or not even wait. We should. Oh wait, I know what happened. Part.anchored is equal to true. Yeah, the part probably fell out the map. And then I'll wait like 1 second or something. And then I'll make this look for it for like 5 seconds. How about that? There we go. Nothing printed? My part. Why is it not making... Part is instant... Oh, I never parented the part. Bro, I keep making mistakes. All right, here. Part parent is equal to workspace. There we go. I'm looking for a child in the workspace. I never even parented it to the workspace. There we go. Found my part. Even though my part my technically. Even though this part never existed, we initialized it or we made a new part in a different script and then parented it. So that's a really good use case of using WaitForChild, is if we know something is going to be in the workspace later hand, but it is not now, we can use WaitForChild to actually wait for that to be added. And we can say, hey, we can use it in basic syntax terms. We can say, hey, I'm waiting for this part. This part will be here. So I'm going to use WaitForChild to find this part, or wait for this part to be loaded. That's my thought process on it. And then the last method. So these methods, we've been searching downward. We've been searching in children, looking down inside of parts or instances. The next method is looking up. So for the most part, when you usually look for a parent, you're usually doing my part is equal to workspace, WaitForChild, my part, dot parent. And this is the workspace. The part of my part is the workspace, right? The parent. Well, sometimes it's really hard to find the parent of those types of instances. It can be a whole thing. And in the last video, I showed you when I was looking for a player. So we can do like game.players.player added connect a function of player, if you remember. And then which is really nice is since we have player, we can actually say local character is equal to player.character. And then we can say like player.character added connect a function, or not even. But in the last video, I had character, and when I was looking for the character from the touched event, I was saying like let's do workspace.myPart.touch to connect the function of other part. And I was saying like, oh, local character is equal to other part of FindFirstAncestor, which is a FindFirstAncestor. And then this will find the first ancestor with the name. So I can say like Sullivan Sawyer 27. This is my name on Roblox. And what this is going to do, it's going to find the first, it's going to look up and up and up until it finds the first parent or ancestor really with this given name. And yeah, that takes a little second, you know. It's going to look up and up. It's going to go up the hierarchy rather than down. And that's a really good use case if you're trying to find like models, characters, specific things really. You might not find it going down, but you need to find the parent. So FindFirstAncestor is really useful for that. That's really basically, that's simple of how it works. But that's really about it for FindFirstAncestor. It's the same as child and WaitForChild. They're just going up rather than down. And now the last methods of these children functions a long video, huh? The last methods is the class methods or the type checking methods. So what I mean by that is we can say like local part is equal to workspace FindFirstChild of class or FindFirstChild which is a, which both of these are about the same. They find instead of through names, they find them through types, through data types. And the same thing with FindFirstAncestor, which is a. So if we find first child of class of which is a part, so it would only give us types and not really like names, as in the drop down. It's going to return the part that it finds first. That is a part, really. We have 3 parts, so it's probably going to return like the base plate or something. But you might be wondering, why is this useful? Oh, I use this a lot. I'm going to show you guys exactly how I use it. So in our touched event, remember our parameters other part, we can say local, we can say parent is, or we can say character is equal to other part FindFirstChild, which is a model. And if you don't know what this means, every character in the game is a model. So if I load up the game and I look at my character, I am a model. And basically when other part is going to be any part inside of the model. So any of my children of my character will touch the part, and that's going to be the argument. And basically we're looking like if my left hand touches the part, we're basically saying, okay, find the ancestor, which is a model inside of the part. And that's going to be my character because I'm not going to have models of my character as children for the most part. I hope maybe you have a different avatar than me. And this is a really good way of finding the character because you're basically knowing, okay, because a model is in like a combination of a bunch of parts. So if I load up play right here, and I'll show you exactly what I mean. If I go in the workspace, solve insert, I'm a model. This is a model. This is what I am. My character is a model. And if left hand, for example, touches the part, which one is my part? This is my part. Yeah, I didn't do any prints, but if left hand touches the part, the cube, for example, or this part, the character that is returned is the first ancestor, which is a model, which is gonna be my character, which is really useful because then I could do this. Now, if we have the character, we can say local humanoid is equal to character, so our model, FindFirstChild, which is a orc of class, doesn't matter, humanoid. And now I can say print char.name, so I just know, hey, Sullivan Sawyer's touching me. And then I can say humanoid.health is his minus equal to 5. Something like that. And if you don't know what humanoid is, that's just how we make things like alive in Roblox. Health. Oh, yeah, okay. Because it's always being touched, this is always firing, we should say this. If character and humanoids, then we're going to do this. Okay, there we go. Make sure to use the if statement because sometimes like the floor will touch it, and the floor obviously is not a character. Is this the wrong part? Okay, yeah. Okay, there you go. And look at that. Humanoid is just inside of every character, every single player. This is what gives us life. This is a whole different video. But yeah, it has properties like our health, our speed, stuff like that, which is really nice. and it is a type in Roblox, and that's what makes this so nice, is because for the most part, your models like mobs, enemies, you're going to have just like one humanoid. You can't really have more than one or two, or you can't have like two. So you can just use this because you know there's only going to be one, and so it's only going to return one thing, which is the basic humanoid from you. And these FindFirstChild, which is a model, is so useful too, because I'm not looking for .parent. Just give me the first ancestor, which is a model, which is going to be a character for the most time, you know, for the most part. Like, I don't feel like doing this. Local char is equal to other part .parent. Most people will do this, right? And this is returns usually the same thing, yes. But what if your meshes, like your character has like custom stuff in an avatar, right? What if they have like a model inside of there, or not a model, but like a mesh that has a child? And then now we're looking for the parent, and then like the character is like some like jacket or something instead of like the actual like character. You know, it gets annoying because then you have to do something like this or like this, and then you have to say like .parent or other parent .parent, which this wouldn't even run, so that doesn't even make any sense. Like, it's a whole thing. This FindFirstChild, which is an ancestor, or FindFirstAncestor, which is a like model method. This one is just so useful. I know I yapped a lot, and I probably confused the hell out of you guys this video. Just know, FindFirstChild returns the first instance with the given name or nil, and FindFirstAncestor, FindFirstAncestor returns the first parent. Parents with the given name or nil. WaitForChild waits for this instance to be in the actual game, and look at this, it autofilled it for me. FindFirstChild, which is A, returns the first instance. FindFirstAncestor, which is A, does the same. Most of these are pretty basic, like English syntax. You can figure out what these do just by reading what the name is. Like, okay, I'm finding the first child, which is A, and it can be a part, humanoid, a model, whatever it is. And yeah, that's really about it for this video. If you guys are already a little confused, because this topic does trip out some people, like, oh, well, why do we do this? Then go in the comments, just let me know. I'll respond to everybody. Don't worry about it. And yeah, I hope you guys enjoyed the video. I know I did. I'll see you guys in the next one.